Alright, in this video we're going to be making a calculator for Cohen's D. Cohen's D is a pretty easy calculator to make. You really only have three things that you're putting in. This is a Cohen's D for when you have one sample and a population. Later, there will be a calculator for when you have two samples. Cohen's D is something that we use often in different situations. And it's not the same calculator because we'll have two standard deviations that we're dealing with. Again, this is for a population, so you can use the population standard deviation. But when you have two samples, you have to kind of average the sample standard deviations together. Don't worry about it yet. We will make another calculator when we get there. For now, though, we're going to make this Cohen's D calculator for a population. What we have here is, this is our population mean, this is our sample mean, and this is our population standard deviation. Also, this is a D. I don't know why it looks like that. So let's put in the things that we need to know. Population mean. Sample mean and population standard deviation. I'm going to move that out a little bit just so we can see what that says. Let's color these green so we know it's something that we need to put values in for. And here we're going to call this Cohen's D. And let's color that yellow. What mean? What should we give this? A mean of I don't know, 50. No, it's too round and obvious. Let's do 52.8. Okay, the population mean is 52.8. The sample mean is 57.1, and the population standard deviation is, let's make it kind of small. Let's say the population standard deviation is 2.7. That sound? Yeah, 2.7 is good. All right, 2.7. So we're going to want to throw some parentheses on here, right? Where do you think we're going to want to throw some parentheses? Right here, the top. We have to throw parentheses on the top. Why? Because if we don't, Excel is going to think that the first thing we do is divide the sample mean by the population standard deviation. That's not what we want. We don't want that. Actually, you know what? I'm going to change these values. Nope. We'll change them later. Let's just do it as is. So an equal sign. We always start with an equal sign. Let's do some open parentheses. And we're going to take the population mean minus the sample mean. Close our parentheses. And now that we've got that phrase together, we can put that over population standard deviation. Go ahead and hit enter. And we have a Cohen's D of 1.59. Here's something about Cohen's D. We usually don't talk about negative Cohen's D. We have t-scores and z-scores to tell us what direction the sample is relative to the population mean. Is it higher or is it lower? So we usually talk about Cohen's D in terms of an absolute value. So one thing that you might want to do to your calculator here is put in ABS, open parenthesis, and close the parenthesis at the end. ABS is an Excel command that is going to return the absolute value. So instead of just the Cohen's D that we've just calculated, where we had negative 1.59, if I put abs and then parentheses around the whole formula, it's going to give us just the absolute value of what we just calculated. And so if I hit enter, it gives us 1.59. It doesn't matter if this is positive or negative, it's always going to be positive, basically. So look, we can take the sample mean and we can make it less than the population mean, so we could say it's 50. and it's still positive. We could make it 60, and it's still positive. And there's Cohen's d. Do you want to get crazier with Cohen's d? Let's talk about Cohen's d for a second. There are benchmarks along with Cohen's d. We need to know the size, right? I mean, Cohen's d gives us a metric of how far apart our two means are in standard deviation units, right? So if we said that our population mean was 20, and our sample mean was 23, and our standard deviation was 1.5, it gives us a Cohen's d of 2. Why is that? Well, it's because if you subtract 20 from 23, you have 3. Divide that by standard deviation units, which is 1.5. Well, sorry, divide that by the standard deviation, which is 1.5. And it puts that difference in standard deviation units. Instead of just numerical units, 1, 2, 3, 4, each one is spaced like numbers are. You're changing the spacing to be the spacing of the standard deviation. So it's kind of like standardizing it. It's a little bit like a z-score in a way. You can kind of think of it sort of like that. We're looking at the difference between a sample and a population in terms of standard deviation units of the population. When we get to doing two groups, you're going to be looking at the difference between two groups in standard deviation units that are common between both groups. And so you need to know when you're comparing two effect sizes against each other, which one's meaningfully larger. So you can say Cohen's d of 0.2 is smaller than a Cohen's d of 0.3, therefore this thing is much more significant, the one that has 0.3. That's not exactly true. We have these benchmarks here. 0.2 and above is a small effect. 0.5 and above is a medium effect. And 0.8 and above is a large effect. Anything less than 0.2 is no effect. So if we had 0.2 and 0.3, we could say this one's a little bit larger, but they're both small effects. If we have something that's a 0.9 and a 1.0, we can say these are both large effects. So that kind of gives us an idea of how big of an effect we're actually dealing with. So we can do something else. This is what you need to know. If you want to build your calculator like this and you want to put these things in there, you can be done. You can listen to this little tidbit of information that I'm going to give you. Jacob Cohen was a super famous statistician. Most of the effect sizes that we have actually come from Jacob Cohen. He's a psychologist. And one of his most famous books, not the most famous book, but maybe the second or third one down the list. The author list was Cohen, West, and Aiken. So this is a book that he co-wrote with his wife and Steve West and Leona Aiken. Both Steve West and Leona Aiken are instructors in the psychology department here at ASU. I was lucky enough to take classes with both of them. They're absolute giants in the field. It's really, really cool to take a class from someone who was instrumental in the way that regression works, or the way that multiple imputation works. Multiple imputation, by the way, nothing you're going to have to deal with in an introductory statistics class. But essentially, it's if you have missing data, how do you deal with that? And Steve West is one of a few people who's instrumental in creating the procedure for multiple imputation. Okay, so we can do something pretty cool if you want. So if you are an advanced user and you would like Excel to tell you what's going on with your Cohen's d, you can add this to your calculator. We're going to start with an equal sign, and then we're going to type in if. This is like an if-then statement kind of thing, if you're familiar with programming at all. So what this is going to do is we're going to give it a condition. We're going to say if condition A is true, then give us this result. If it's not, give us a different result. What we can do is we can take these statements and nest them and have it give us a bunch of different outputs if any condition is true. So here's what we're going to do. We are going to say if cell E2 is greater than equal to, what? Greater than or equal to 0.2. Then we're going to put in parentheses small. So this should output the word small if this is true. And now it wants to know the value if this is false. Well, we're not done. We don't just have an either or. We're not done. We can't just say medium here, because then it would say, everything is either small or medium. So we're going to have to put in another if statement. So if E2 is greater than or equal to 0.5, we're going to have it display the word medium. And we need another nested if statement. So if E2 is greater than or equal to 0.8, we're going to have it tell us that it's large. And now is the last. We don't need any more nested if statements. The only thing to do after this is it's either greater than or equal to 0.2. It's either greater than or equal to 0.5. It's either greater than or equal to 0.8. If it's not, then we're going to have it tell us no effect. You know what? I just realized that we did this incorrectly. So we're going to have to change some numbers around here. By the way, you need to fill in the number of parentheses that you ended with. So you can count up the number of open ones. We've got 1, 2, 3. So you need to put in 1, 2, 3 parentheses here. This is going to give us the wrong result, because it is going to be greater than or equal to 0.2 if it is also greater than or equal to 0.8. So it's going to display small and not even go to the next step. So we need to start with the largest one. So it's either greater than or equal to 0.8, and that'll tell us large. We can leave 0.5, and that can be medium. And here we're going to be changing this to 0.2, and this is going to be small. Now, if it's not greater than or equal to 0.8, then it's going to see if it's greater than or equal to 0.5. Then it's going to see if it's greater than or equal to 0.2. Otherwise, it's going to say no effect. So this should work. Hey, it didn't. That's excellent. I honestly don't know what typo it corrected. Possibly a comma? I don't know. I don't know what it corrected. But whatever. This is the formula. It seems like what I typed in. I think it put zeros. I think it just changed it to 0.8 instead of 0.8. So let's see if it worked. So we've got a large effect here, but let's change the sample mean to 21. Hey, excellent. We've got a Cohen's d of 0.67, and it's a medium effect. Now we can make it even smaller. What if this was a standard deviation of 2? Need to go smaller. What if it's a standard deviation of 3? It's a small effect. And what if it's a standard deviation of 10? No effect, because we have 0.1. Here is your Cohen's D calculator that now even tells you what effect size you have. So, or what benchmark you meet with your effect size. A little bit more sophisticated than the other one. If you watch this and you're confused, just stick with the number here and you can fill in the benchmarks yourself. So, kind of like a one size fits all in a way. Okay, that's it for Cohen's D. And I'll see you in the next calculator video.